In graph 10.4 we showed how changes in income usually shift own price demand curves, and changes in utility levels usually shift marginal willingness to pay or compensated demand curves. Of course, there's no particular reason why we can't put own price demand and compensated demand curves on the same graph, and we'll do that here to show how they are related to one another. We'll use gallons of gasoline as an example of a normal good, and start with an initial blue budget constraint that contains the price P per gallon of gasoline. Our optimal bundle under these circumstances is bundle A, allowing us to reach the indifference curve labeled UA. We then suppose that the price of a gallon of gasoline goes up to P prime, forming the new magenta budget constraint. And our new optimal bundle on that magenta constraint is bundle C, allowing us to reach utility level UC. We can decompose this behavioral change into income and substitution effects by illustrating the compensated budget as the budget that has the same slope as the final budget but is tangent to the original indifference curve. This gives us our usual bundle B, which we'll need in order to be able to derive the compensated demand curve. When we drop bundle A down to point A on our demand curve diagram, it settles at the height of P1, which is the slope of the blue budget constraint. Bundle C, on the other hand, happens at the higher price P prime, and therefore settles at the higher height of P prime 1. Notice that C occurs on a different indifference curve than A did, and so C and A will not lie on the same compensated demand curve. But C and A occur at the same income level, and therefore occur on the same own price demand curve. Bundle B also occurs at the higher price P prime, and therefore falls at the same height in the lower graph as bundle C did. Notice that bundle B and A lie on the same indifference curve, and therefore will lie on the same compensated demand curve. But they involve different income levels because we had to compensate the person to get him to be able to consume bundle B at the higher prices. Therefore, B and A do not lie on the same own price demand curve. Connecting A and B therefore results in the marginal willingness to pay or compensated demand curve that's derived from the indifference curve UA, on which both A and B lie in the upper graph. Connecting C and A, on the other hand, gives us our own price demand curve given the income level IA that the individual had at the original bundle A. As we move up along the own price demand curve, income stays constant, but the individual becomes less happy. In other words, utility level falls as we move up the own price demand curve. Analogously, on the compensated or marginal willingness to pay curve, as we move up that curve, income increases because we have to compensate more and more in order to get this person to be able to remain at the same level of indifference. But utility levels do not change as we move along the compensated demand curve, because we've explicitly assumed that we're giving you enough money to always reach the same indifference curve. The sequence in panel A assumed that gasoline was a normal good. You can tell that we assumed that because point C lies to the left of point B in both the upper and the lower graphs. We'll now investigate a slightly different case, where we'll assume some arbitrary good x1, and we'll assume that x1 is in fact a quasi-linear good. Assuming that x1 is a quasi-linear good is the same as saying that we're assuming that there's no income effect for the good x1. Thus, as we move from the final budget to the green compensated budget, the consumption level for x1 does not change, and bundle B, therefore, occurs right above bundle C. Bundle A can be brought down to the lower graph just as it was in panel A, settling at the height of P1, which is the price along the blue budget constraint in the upper graph. Similarly, bundle C occurs at the steeper budget in other words, the higher price for the good x1, and thus settles at the higher level in the lower graph. The same is true for bundle B, except now that bundle B lies right above bundle C in the upper graph, it ends up lying right on top of bundle C in the lower graph. Connecting B and A gives us the marginal willingness to pay, or compensated demand curve, corresponding to indifference curve UA. Connecting C and A, on the other hand, gives us the own price demand curve for the income level that this individual has at bundle A. Since C and B are the same point in the lower graph, this implies that the own price demand curve, corresponding to the income level the individual has at bundle A, is exactly equal to the marginal willingness to pay, or compensated demand curve, corresponding to the indifference curve that individual has at bundle A. Unless the underlying good is quasi-linear, the marginal willingness to pay or compensated demand curves are therefore not the same as the own price or uncompensated demand curves. When the underlying good is a normal good, the marginal willingness to pay curves will be steeper than the own price demand curves as shown in panel A. You can similarly convince yourself that since bundle B will lie to the left of bundle C if the underlying good is an inferior good, the marginal willingness to pay curves will be shallower than own price demand curves in cases where the underlying good is an inferior good. Of course, there isn't just one marginal willingness to pay curve, just as there isn't just one own price demand curve, as we showed in graph 10.4. Rather, along any demand curve, like the magenta curve in panel A, there is a marginal willingness to pay curve that crosses at every point along that demand curve, because as we move up the own price demand curve, the individual becomes less happy, and there's a marginal willingness to pay curve that corresponds to each indifference curve. Similarly, there's an own price demand curve that crosses any given marginal willingness to pay curve at every point. As we move up the marginal willingness to pay curve, we have to increase income levels in order to keep utility constant. And for each different income level, there's a different own price demand curve. Again, the one special case where this is not true, where we don't have to worry about the difference between own price demand curves and marginal willingness to pay curves, is the case of quasi-linear goods.